We've traveled from single neurons to deep networks, from CNNs that see to RNNs that remember, from LSTMs that don't forget to transformers that see everything at once. Now we arrive at the destination, large language models, or LLMs. The AI systems that are changing how we work, create, and think. The core idea behind LLMs is deceptively simple: predict the next word. Given the sentence, "the cat sat on the," what comes next? Probably mat, or chair, or floor. The model learns to predict the most likely next word. That's it. That's the training objective. Just next word prediction. But here's what's remarkable. When you train a transformer to predict the next word on trillions of words from the internet, books, and articles, something incredible happens. The model doesn't just learn grammar. It learns facts, reasoning, coding, math, poetry, humor, and even common sense. Researchers call these emergent abilities. They weren't explicitly programmed. They emerged from the sheer scale of training. This is the scaling law: make the model bigger, give it more data, train it longer, and it reliably gets smarter. Not just a little smarter. Qualitatively smarter, developing entirely new capabilities at each scale. Training an LLM happens in stages. Stage 1 is pre-training. The model reads an enormous amount of text, essentially a big chunk of the internet, Wikipedia, books, code repositories, and scientific papers. Through billions of next word predictions, it builds a deep understanding of language, facts, and reasoning. This stage takes weeks on thousands of GPUs and costs millions of dollars. But the raw pre-trained model isn't very useful yet. It can complete text, but it doesn't know how to have a helpful conversation. Stage 2 is fine-tuning. The model is trained on carefully crafted examples of helpful conversations, questions and answers, instructions and responses. This teaches it how to be an assistant. Stage 3 is alignment using a technique called RLHF, reinforcement learning from human feedback. Human raters compare different model responses and pick the better one. The model learns from these preferences. Think of it like a chef who cooks several dishes and lets taste testers vote on which is best. Over time, the chef learns what people like. Anthropic, the company behind Claude, also uses constitutional AI, where the model critiques and improves its own responses based on a set of principles. And that brings us to today. We've traveled from a single artificial neuron in 1958 to large language models that can write code, explain science, create art, and hold thoughtful conversations. The core ideas haven't changed: neurons, weights, training loops, gradient descent. But the architecture's evolved, from perceptrons to deep networks, from CNNs for images to RNNs and LSTMs for sequences, and finally to transformers and LLMs that can understand and generate human language at remarkable levels. The journey is far from over. AI is evolving faster than ever, and understanding these foundations puts you in the best position to understand what comes next. Thanks for watching.